Hey children, myself Naresh Ramraj. In this video, we are going to discuss about the chapter Light from 10th class CBSE Physics. Light. The chapter Light is the first chapter of physics in your 10th class CBSE, where we will discuss about the phenomena of reflection and refraction. Reflection and refraction. So generally, before diving deep into the chapter of light, we'll study what is light first. What is light? So light can be said as it is a source of energy. Generally, you people say no, it is a source of energy. Yes, it is a source of energy which creates the sensation of sight. This is what we know. And we have even seen that light is responsible in order to see object. That means whenever light from any source, which can be a luminous source or non-luminous source. Luminous source and non-luminous source, you people might have studied in your earlier classes like 6th and 7th classes. So light from a source, say for example, if I consider a source in this way, a source can be a bulb, it can be sun, or it can be a candle in such a way. The light from the source must be incident onto in the sense it must fall onto a object, and from the object it must reach the naked eye. In such a way we will be actually able to see this object, and in the absence of light we are not actually able to see any type of object. That is why in the evenings or in the mornings, whenever there is a power cut, mornings in the sense early mornings, so we will be like literally crawling to get some things. Where is this thing, that thing and all, because of the darkness present there. And what is darkness? No light is said to be as darkness. Yeah, so in this way, whenever there is an absence of the source, the light will not be falling onto any type of object and will not be able to see that object. So light source is required in order to see an object. Very clear, right? So now what are you going to study in the 10th class chapter light? Before diving deep into the topic, let us study how light actually travels. Say for example, if I want to travel from my native to a city, what is the medium of my traveling? It can be a bike, it can be a car, it can be an aeroplane. So these kind of. So how am I able to say I have traveled on bike, I have traveled on an aeroplane, I have traveled in a car? So in such a way, even light requires some medium. Okay, so obviously here the medium will be having some of the physical properties. That also we'll study in the near future in the next videos. So light can travel through medium, and even in the absence of medium, that is said to be as a vacuum, there also even the light can travel. Okay, so light travels in both medium and vacuum too. You may ask me, sir, what can be the example? It requires medium. You can see the light traveling through water. Yeah, even in the water it is visible. And generally we are actually surrounded by air. Air is said to be as a medium, and there also the light is visible. But whenever the light travels actually from sun onto the earth, there it has to travel through vacuum and even the media. What are the media here? It can be air, it can be water vapor, it can be the clouds which are present in the sky, or in the layers of the atmosphere, which you might have studied in your lower classes. So light travels in both media and vacuum. And now, what is the nature of the light? Some scientists discuss nature of the light. Some scientists say it is having a particle nature, and some scientists say it is having a wave nature. Now, what is this particle nature? What is this wave nature? Nature in the sense, the nature of the light, how it actually travels and how it has its own behavior to travel. So there we do have particle nature and wave nature. Particle nature and wave nature. So about the wave nature, obviously we'll study in the higher classes, which is not actually required in 10th standard CBSE or even the state boards of Karnataka, state boards of Andhra Pradesh, Telangana, Tamil Nadu, whichever we discuss. Here we won't much discuss about wave nature. We discuss and we stress on the nature of particle nature of light. So light travels in the form of particles. And what are those particles called as? They are called as photons. And the energy possessed by them, energy possessed by these photons is said to be as quanta. Okay, light travels in the form of photons and the energy possessed by those photons are said to be as quanta. And in this particle nature of light, generally we have the properties of the light basing on the particle nature of light as well as wave nature of light. But clearly we are going to study in 10th class CBSE only about the particle nature of light and the properties of the light which are actually dependent or studied on particle nature of light. Okay, let us discuss the same. So depending on the particle nature of light or wave nature of light, we do have 7 properties of light. What are those properties of light? Let us see. Properties of light. So those 7 properties of light, the first one is rectilinear propagation. Rectilinear propagation. The second one is reflection. Third one, the other one, refraction. Fourth one, diffraction. The other one, polarization. One, two, three, four, five. The sixth one is interference. And last but not the least, photoelectric effect. So these are all the 7 properties of light. Okay, and what is useful to study all these properties of light? The nature of the light. So depending on what are the 2 natures we have, particle nature and wave nature. So whenever we study the particle nature of the light, we do study about these 3 properties of light which depend on the particle nature: rectilinear propagation, reflection and refraction. And whenever we study the properties of light such as diffraction, polarization, interference and photoelectric effect, they all do come under the wave nature of the light. So obviously, as we discussed or as even stated in the CBSE syllabus of 10th class, we even study only rectilinear propagation, reflection and refraction in light reflection and refraction chapter. Yes, now if we discuss the first property, let us discuss the first property. What is that property? Rectilinear propagation of light. Name itself has it. Rectilinear. Linear. Linear in the sense? Linear. Line. Straight line. Yeah. So the rectilinear propagation of light says light travels in the form of straight lines. Light travels in the form of straight lines. So now if we discuss about rectilinear propagation, say for example, we have taken a source. Let us consider sun. Let us consider sun is the source of light here. And whenever light is incident from the sun, So in this chapter we are going to believe the particle nature, and we even study the particle nature, and then we have come to a conclusion that we must follow light travels in the form of straight lines, which is said to be as the rectilinear propagation of light. Rectilinear propagation of light. Rectilinear propagation, it says that light travels in the form of straight lines. So here you may get some doubt. Sir, it travels in the straight lines. Whenever we have studied mathematics, CBSE, or in our lower classes, straight lines are there, sir, for sure. But we do have even parallel lines, sir. You may consider these as rays, and you may consider this kind of as straight lines, no? Yeah, we can consider them as rays only because they are coming out from a source, and we do treat them as rays. Light travels in the form of straight lines. Yeah, they travel in rays. So these rays can be parallel, no sir? Sir, these rays can be anti-parallel, no sir? Sir, these rays can travel towards each other, no sir? Sir, these rays can travel away from each other also, no sir, because they are rays. Obviously, what you said is correct. Yeah, and we do consider, before going to that, we do consider these lines as a beam of light. Collection of these straight traveling straight line light rays is said to be as a beam. In simple words, collection of these light rays is said to be as a beam of light. Now this beam of light, whenever the light rays are parallel to each other, this is said to be as parallel beam. Parallel beam. We don't have anti-parallel beam. Why? If we do consider two sources, if we are studying with two sources, say for example, here there is a source 1, here there is a source 2. So now from source 1 it is coming towards me, from source 2 it is going away from me. What is this? Light. So here you may consider this beam of light are anti-parallel. Here we don't study two sources of light. Yeah, they can be used for engineering or other scientific purposes, but in this chapter we are not going to study. So what are you going to study? Parallel beam of rays. And these beam of rays, if you see, they are trying to meet at some single point indirectly. So they are said to be as converging. So they are said to be as convergent beam. And if you see these light rays, they are going away from each other. Like soon after the school long bell, turn, as you people move in random without even hearing to the PT sir or whatever the master who is guiding you. In such a way, they move away from each other. This beam is said to be as divergent beam, because they are diverging from each other. Diverging in the sense separating away from each other. So in rectilinear propagation, what we have studied? Light travels in the form of straight lines. And we studied what is beam? Collection of those light rays. And if those light rays are traveling parallel to each other, they are said to be as parallel beam. And if those light rays are moving towards each other, are said to be as a convergent beam. If those light rays are moving away from each other, is said to be as a divergent beam. So this is about rectilinear propagation. Now, what is the second phenomena involved in the properties of light? This one. So this is said to be as, the second one is reflection of light. The second one is reflection of light. Let us see what is that reflection of light. Boom, boom. You are going to rub this. Reflection of light, the second property. Is it so very useful? Obviously, yes. Reflection is so very useful. How reflection is useful actually? Because generally, even in the starting of this video, we have discussed how we are able to see the objects, because light is incident from the source onto the object, and from there it bounces back into our eye. Then we will be actually able to see it. So there are many things which are happening only on some of the properties of light. I mean all the properties of light. and on some of the properties like reflection and refraction, which we are going to study now, there are many phenomena involved. Okay, so now what is reflection of light? Reflection of light. Yeah, reflection of light. Please carefully listen to me. Reflection of light is termed as, it can be proclaimed as, or it can be defined as bouncing back of light. Bouncing back of light. Bouncing back of light into the same medium when light is incident onto a polished surface. Clear now? Yeah. What is this bouncing back? Say for example, from a bulb, let us consider this bulb. So it is giving out some light rays, as we discussed, rectilinear propagation. So some of the light rays, these light rays will be falling onto an object, and from there, if they bounce back, this phenomena or this property of light is said to be as reflection of light. Why did we mention medium? Because when there is a change in media, when light is actually coming back or it is actually trying to travel, if there is a change in media, then it becomes refraction, and that we will study in the further videos. Again, coming back to reflection. What is reflection? Reflection is bouncing back of light into same medium when light is incident onto a polished surface or onto any object. Okay. Yes. So reflection of light is bouncing back of light when into the same medium is mandatory, because if the media is changed, that light rays will actually behave in a different way. So mentioning medium is important here. Now in order to study the reflection of light or even the refraction of light, we should have some basic knowledge on what are the light rays. In the sense, say for example, if we consider a source, some of the light rays are coming from the source, and even in the previous example only, some light rays are bouncing back from the object, right? So we have to study what are those light rays. So those light rays are incident ray, reflected ray. We do have refracted ray also, which is quite similar to this, that we will discuss in refraction. Incident ray, reflected ray, and normal. We'll discuss what is normal. First, what is incident ray? Obviously, that which comes out from the source. The light ray which comes out from a source and incident onto, we should not use incident, no. The light ray which comes out from the source and falls onto a object. OBJ. This type of ray is said to be as incident ray. What is this? Incident ray. And which actually reflects from this object is said to be as a reflected ray. Reflected ray. And we do have another one. What is that? Normal ray. Why it is normal? Okay, let us consider the small portion of this object. Yeah. Okay, small portion of that object. Okay, in this way the light incident has been coming, and in this way it is actually reflected. So now, in order to know or in order to study how this reflected ray behaves to this incident ray, we require one reference. So that reference is said to be as a normal. You might have studied in your mathematics what is normal, what is orthogonal, what is perpendicular. So the same says here, normal is a perpendicular. Say for example, if you consider a plane at this incidence, at the point of incidence, if you consider a plane at this point of incidence, So at that point of incidence, if we draw a perpendicular to this plane, that is said to be as a normal ray. Acha, let us discuss again. Incident ray, that ray which actually comes from the source and is incident onto an object or falls onto an object. Reflected ray actually bounces back from that object. That is why it is said to as reflected ray. And normal ray, which is actually orthogonal or perpendicular to the plane of contact. This plane of contact, if we consider, the perpendicular line is said to be as normal. And why do we consider this normal? Normal must be considered because it stands out to be a reference how the incident ray and reflected ray, I mean how the reflected ray is behaving to an incident ray. Clear now? Why normal is necessary? I'll tell you some simple example. If I draw a line and if I ask you, is this smaller or a taller one? You can never say. But if you draw another large line beside it, now if I ask you, which is the taller one? You will obviously say the right one. Which is the shorter one? You will obviously say the left one. The same way, if you consider the smaller line actually, so that smaller line is said to be as a reference to this line. Now you will say this is a smaller line and this is a larger line, right? So a reference is always required to show something or to prove something or to study something. In such a way, the normal is required in order to study this incident ray and reflected ray. And in simple words, normal is required to study the behavior of reflected ray whenever an incident ray is incident onto a surface. Clear, no? Yeah. So now in this reflection, we do have two types of reflections. So what are these two types of reflections? What are those? Regular reflection and irregular reflection or diffused reflection. Sir, what are these? Regular reflection and irregular reflection. Regular reflection. Let us consider a plane mirror. Again, what is a mirror? Generally, we do see images in that, sir. Exactly. And this regular reflection and what is this? In order to explain them, let us consider a plane mirror where whenever light ray is incident onto it from a source. Now we assume there is some imaginary source. It can be a bulb, sun, candle, whatever you consider. Now, whenever the light ray bounces back, this is said to be as reflected ray, whereas this is incident ray. And for what is that? Reference, we do have normal ray. And we have seen normal is always perpendicular to the plane of contact. Okay, so here if you see, these kind of incident rays will obviously have reflected rays, and this plane which is actually regular or in the form of flat surface. Now if this plane is not flat, and what is this actually? This is said to be a silver coating, glass coated with silver in the lower portion of it, and light is incident onto it. Now it behaves like a mirror. Yeah. So here this is a irregular, this is regular reflection, and this is irregular reflection or diffuse reflection. Now incident ray, say for example, it is incident in this way, it goes in this way, this is the normal. Now incident ray itself is incident in this way here, and now reflected ray is going in this way. Normal is here. So if you consider these normals as n1 and n2, these normals are not parallel to each other. Whereas in regular reflection, the normals are parallel to each other. Consider this as n1 and this is n2. Normals are parallel in regular type of reflection and normals are not parallel in irregular type of reflection. Clear, no? Irregular or diffuse reflection, where the plane of contact of the light on which it is incident is irregular, is not planar. Whereas plane of contact of the regular type of reflection, in regular type of reflection, the plane of contact is flat and the normals are parallel to each other. Clear, no? So these are the two types of reflections. But in order to study the reflection, now we are going core into the reflection. We are going to study clearly about reflection. So we have seen that reflection, any type of reflection will actually have three light rays. What are those light rays? Incident ray, reflected ray and normal. Incident ray, reflected ray and normal. In order to study how this reflected ray behaves to an incident ray with reference to a normal ray, we must study the laws of reflection. Laws of reflection. Laws of reflection. We do have two laws. Let us consider the first law. First law. The first law of reflection says, why it has become a law? Because it has been observed that all the time, whenever reflection happens, let us consider a plane mirror. Whenever reflection happens, that means whenever incident ray is incident onto a polished surface and reflection happens, whereas this is incident ray and this is reflected ray, we do have normal as reference. The first law says the angle of incidence is equal to angle of reflection. What is this angle of incidence? Reference and incident ray. Reference and incident ray. They are meeting at this point and they are inclined to each other, and that inclination is said to be as angle of incidence or incident angle. Clear? And again, what is angle of reflection? Reference and the reflected ray. Reference and the reflected ray. They are inclined to each other and they form angle of reflection. The first law says the angle of incidence is equal to angle of reflection. That is angle I is equal to angle R. Angle I is equal to angle R. What is the second law? Let us see. Second law. Second law says incident ray, reflected ray and normal, all the three rays Govinda, okay, they all lie on same plane. They all lie on same plane. What is this plane, sir? Actually, we do have no points, planes, points, straight lines, planes and solids, right? Points, this is a point, this is a straight line, and if we consider this comes under a plane, and we do have, say for example, a cube or a cuboid which is actually 3D in nature, this is said to be as a solid. So now let us consider this is a plane, no, that means this is measurable in two dimensions. One dimension, let us consider it as x, another dimension, let us consider it as y. Clear, no? So if this 2D okay exists, yeah, it actually exists. And now the second law actually says the incident ray, normal and reflected ray, they all lie on the same plane. Now you may ask me, sir, say for example, if I am able to see your hand, I am able to see this, what is this marker? Is that a plane, sir? No, this is not a plane. Obviously this is a solid. But if I consider one ray of light incident onto this, you may assume it as a laser beam, no problem. Incident ray can be assumed as a laser beam. Now when it is incident onto this, when it undergoes reflection and the normal at that point of incidence, for sure all of them will be in a same plane. That means they all can be studied in just with the help of two axes. So that means they all lie on a same plane, right? So second law says incident ray, reflected ray and normal lie on same plane. Lie on same plane. Clear with this now? Yeah. I repeat again. If we study laws of reflection, what is first law? Angle of incidence is equal to angle of reflection. What is second law? Incident ray, reflected ray and normal lie on same plane. Now you may have a doubt. Sir, are these valid for both regular reflections and irregular reflections? Whenever reflection happens, even for a single light ray, these are valid. Not for a single light ray, every light ray. So for irregular reflection as well as regular reflection, the laws of reflection are valid. Right? Yeah. Now let us see. When we discuss about reflection and when we discuss about mirrors, we have seen or discussed that some images can be seen. What is this image actually? That we have. So children, now we are going to study what is image. So before going to study what is image, now let us see how we are going to actually study the image. How we are going to actually study the image of an object when the light is being reflected. It can be reflected on a mirror or a polished surface. Now let us consider. What do we have studied up to now? There is a source where the light comes from it. It is incident onto the object, and from there when it is reflected onto the naked eye, we are able to actually see it. Right? Clear now? Exactly. But in order to study the image, every time we are not going to study about the source of light. We assume that there is a source of light always. We assume that there is a source of light always, and we assume it as any random source of light, as we discussed. So if we discuss, okay, say for example, there is a plane mirror here and there is an object here. Okay, yeah, let us see. There is an object here. Say for example, let us consider this point. Some light is actually incident onto this point, and from there it is actually incident onto this mirror, and this we will consider as the incident ray from now. So this part where the light is actually from the source but not from the object. So this we will consider. This we will not consider from now. Okay. So that which is actually coming out from the object is taken as a incident ray. Clear now? Yeah. And now there will be a reflection, and this will be a normal. Now this is said to be an object. Clear now? And wherever these reflected rays meet, that is said to be as an image. Wherever these reflected rays meet, that is said to be as an image. Clear now? And where actually for a plane mirror, the images are formed. Let us see. Let us see. Generally, if we stand before a mirror, we will find ourselves in the mirror. But we know which we are seeing is the image, not the original us, who are the object. Right now. So, if you move forward towards the mirror, even the image moves. If you move backward, even the image moves simultaneously. And even the size of you also is not even changed when you are standing in front of a plane mirror. And in other types of mirror we will study in future. Okay, now let us form the image of a point-sized object when it is kept before a plane mirror. Clear now? Yeah. Now let us consider there is an incident ray 1, IR1. So obviously there should be a normal here always, which is n1, and this will have a reflected ray following the laws of reflection. Always please do keep in mind, you have to draw in such a way this angle I is equal to this angle R, angle R1, angle I1. Okay, so this is RR1, reflected ray 1. Okay, now let us consider, we have studied image is formed at where reflected rays meet. Rays in the sense it is a plural, that means minimum number of rays. See, this can come as a MCQ, this can be asked as an MCQ in your exams. How many minimum number of rays are required in order to form an image? 2 are quite enough. Just remember, how many? 2. 2 RRs are required. Reflected rays are required to form a image. To form an image. So now let us consider another incident ray, because we do require another reflected ray, and we do have another normal. This is taken as IR2, this is RR2, and this is N2. Sir, you have said wherever the reflected rays are meeting each other, there the image is formed. But if you see here, sir, RR1 is moving towards upwards and RR2 is downwards. What should we do in this case? Because no image is formed, and you are saying that when we stand opposite to A or in front of a plane mirror, we are getting the images of them. Yeah, to study that we have to extend. These reflected rays in the opposite direction. Such that they meet at a point, creating the image of that object. Let me repeat again. They must be extended in opposite direction. Then they are said to be as extended reflected rays. So they are extended in the opposite direction, and they are made to meet to form an image. You may ask me, sir, you are making them extended in on the board. In the reality, how is it possible, sir? Yes, whenever these reflected rays, though they move away from each other, they are tending to meet at some points where the image is formed, and such a type of image is said to be as a virtual image. Are you clear? Virtual image. What is a virtual image? Whenever the extended reflected rays meet, they form virtual image. Sir, if you are saying virtual image and virtual image, there must be some other types of images also. Yeah, we do have images of two types. What are those? Real image and virtual image. Real image and virtual image. So what is real image? Real image is formed whenever the reflected rays directly intersect each other and meet at a point. But here the real reflected rays are not meeting, and they are tending to meet at a point virtually. That is why they are said to be as a virtual images. Clear now? So two types of images, real image and virtual image. So it is clear that when we stand before the plane mirror, which type of images are formed? Virtual images are formed. Okay, and how are they? They are erect. You may ask me, sir, erect, what is this? Erect in the sense, if I am standing straight, this in the same orientation, or in the same phase, or with the same angle, even the image is also formed. That is said to be as erect. But when it is anti-parallel, that is said to be as inverted, which we will be discussing in the future. Okay, so whenever the point object, or if you take any object, okay, even if I consider, let us see, now I'll put one object of a particular size, consider this arrow. Okay, now incident ray from this, incident ray from this, and reflected ray from this. Okay, so from the head, in order to form the image of the head, image, two incident rays are required. Fine, so I'll take this as IR1, this is IR2, sorry, RR1, and this is N1. We require another incident ray which is said to be as IR2. And what about this here? This is normal incidence, perpendicular incidence only, no? Perpendicular. So obviously even the normal will coincide with the incident ray, and even reflected ray also. Why? Because first law of reflection says that the angle of incidence is equal to angle of reflection. In such a way, whenever the angle of incidence is 0, it implies angle of reflection is also 0. So that means itself is IR1, sorry, itself is IR2, itself is RR2, itself is N2. So in this way we do have RR2, in this way we do have IR2, but this RR2 and RR1 are moving away from each other. Now they must be tended, that means extended to meet at a point, and there the head is actually formed. Okay, in the same way, even for this also, I'll take one light ray from here, it reflects in this way, would have a normal. I'll take another light ray normal, it reflects back. In such a way, when they are extended, here the body of it is formed such that this is the image of this object. And let me consider this as IR3, RR3, N3, and this one is RR4, IR4, and the normal is N4. This is N1, and here also N2 is present. In such a way, virtual image, how is it? In the same orientation. So erect image, virtual image, erect image, and we do have one more small property which actually this image has, is the size of object is equal to size of image. Clear now? Size of object equal to size of image. Okay, so whenever any object is placed before a plane mirror, they do form some images, obviously. And how are they? They are virtual, they are erect, and size of object is equal to size of image. But now one of you will ask me, sir, but my right hand seems to be left hand of my image, and left hand of me seems to be right hand of my image. Exactly. Let us discuss what is that. And here we know light always takes shortest path to travel. We know light always takes shortest path to travel. Okay, so from my right shoulder, the image left shoulder is nearer, or I must say the parallel rays from my shoulder, when they are incident onto the plane mirror, if there the image is formed, if there, obviously there only it is formed, because light takes the shortest path to travel. In such a way, my right seems to be left and my left seems to be right. Okay, the phenomena in which the right side of the object seems to be the left of the image and left side of the object seems to be the right of the image, such phenomena is said to be as lateral inversion. Such phenomena is said to be as lateral inversion. What is this lateral inversion? The phenomena in which the right side of the object seems to be left side of the image, and the left side of object seems to be right side of the image, is said to be as lateral inversion. So in the image formation, when we are standing before a plane mirror or any kind of mirror which is actually reflecting the object, okay, there lateral inversion is possible. Okay, and in the image formation due to a plane mirror, what are the properties of it? Size of object equal to size of image. That is the first one. Next one, it is virtual. Next one, equal in size. Equal in size is what actually we have discussed. Size of object is equal to size of image. Virtual, lateral inversion. Lateral inversion. Lateral inversion. Clear with this, no? Right? And even we do have erect. So size of object equal to size of image, virtual, erect, and lateral inversion. This is how the properties of image we study when the object is kept before a plane mirror. And if you are up to here, kindly please do subscribe, share even these videos with your friends, and support me. Thank you. See you in the next video. Bye bye.